Okay, so welcome again to this session on Reactive Streams in Java 9. For all those who came here for the Android testing session, it's not going to happen because the speaker is not there, so you are free to go away. I saw some confused people in the entrance. So. And I'm happy that someone has come here, even though there was a party yesterday, so let's hope that's going to work today. So I'm Jacek Kunicki, I work at Software Mill. At Software Mill we write code like pretty much of all of you here do, but there are two things that are unique about Software Mill. The first one is that we are a remote company, so we don't have an office. And the second one is that we have no managers, which results in a flat structure and full transparency and some things like that. So if you are eager to hear the story, please catch me or some other people from Software Mill later. Today we're going to talk about reactive streams in Java 9, so let's start with a quick recap of what reactive stream processing is after all. So if you imagine a typical stream processing pipeline, sorry, can I have the timer set on the screen because it's like fixed? Okay, so if you imagine like a typical stream processing pipeline, you start with some source for your data. Then you have some destination for your data. You can call it a consumer. Perhaps you have some intermediate stages that are doing the processing of the data. And you have data flowing from left to the right, so from the producer to the stages to the consumer. And now if you start thinking what can go wrong in such a setup, then the problem that may arise is that the producing stage, so like the previous one, is faster than the next one, so than the consumer. And then you have several ways to deal with this situation. Like the most trivial one would be to drop the excessive data, basically, and that's what happens, for example, in some lower level stacks like networking hardware. The other solution is to buffer the data, but as you know, buffers are limited, so if you are not able to buffer the data infinitely because the buffers are going to fill up eventually, and you're going to lose the memory and have no more of it. The other way is to perhaps block, because if the consumer is blocking, it can just not allow the producer to send any data before it stops processing what it's doing right now. And the last way, but not least, to do it is something called a backpressure. And backpressure is basically a mechanism for a slower consumer to slow down the producer. So to tell the producer that, hey, I'm not able to process it, you need to slow down. So this is basically like a kind of data flow in the reverse direction, and it's a way for the slower consumers to tell the producers that you need to slow down. And this is like general terminology for stream processing. Every implementation has its own terminology. So in Java, the producer is called the publisher, and in reactive streams in general, the consumer is called the subscriber, and the stages in the middle are called processors. So this is this is not yet reactive, so this is basically a streaming pipeline with backpressure. So what makes reactive streams unique? Well, the first and the most important thing is that the backpressure should be non-blocking, because once again, the backpressure is the mechanism for slowing down a too fast producer. And if you do it in a blocking manner, there is really not much about being reactive here. In the reactive approach, you really should not be blocking. And the reason for that is that the reactive approach assumes that threads are released as early as possible, and they are not blocked where they are not necessary, which in turn allows you for scaling your applications even on a single machine. Because if you reuse the threads, if you free them when you don't need them, the CPU has the possibility to do some optimizations and use the threads elsewhere. So the important thing here is that we start with backpressure, but it's also important that the backpressure is non-blocking. The other thing that is specific to reactive streams is the fact that the slower consumers are somehow represented in the domain model, so in the domain of stream processing. And I have chosen two examples for that. First is the Twitter API, which is pretty interesting, because if you use the Twitter API, it actually allocates a buffer for the messages it is sending to you as a consumer. And normally it's like putting the actual data messages that you are interested in, but it's also monitoring how fast you consume. And it turns out that if you are consuming too slow, it starts, apart from the data messages that are in the buffer, it starts putting some signaling messages that are basically telling you that, hey, you're consuming too slow, And there are some constraints here, some timeouts, and if you don't get faster in a given period of time, the connection is going to be dropped. So this is basically like a way of representing the idea that something may be slow in the domain model itself, so in the stream itself. The second example is a stream combinator from Akka Streams called conflate. And what conflate basically does is when the slower consumer starts backpressuring, so it starts telling that, hey, I'm not able to process it, so it slows down the producer. Then the producer starts aggregating the data, and only when the consumer becomes available again, it tells that it can process the data. Then the data is sent in some aggregated way. And then you have some flexibility when it comes to how the data is aggregated. You can go more or less generic depending on what tools you have and what needs you have. But this is again another example where the pipeline itself is aware of the fact that actually something can be slower, and that we are representing it somehow in the domain model. So starting from Java 9, the Reactive Streams interfaces have been incorporated in the JDK. Before JDK 9, there was like this separate library called Reactive Streams, and there were those org Reactive Streams something interfaces. And starting from Java 9, they have been put in the JDK as the java.util.concurrent.Flow interfaces. So those are basically the same interfaces, which I'm going to shortly describe in a second. But they have just been moved from an external library, the org Reactive Streams, into the JDK. So the interfaces themselves are pretty simple. The first one is a publisher, and as you may imagine, the publisher is something that is going to produce data of some given type, and is going to send it to some subscribers that get connected. And the publisher interface exposes a single method, subscribe, which is for registering the subscriber. So if you take a subscriber, you can call subscribe on a publisher, and then the subscriber gets registered and can receive data. So not the second interface, the subscriber, is something that subscribes to the producer to receive data, and it receives a couple of signals. So the first one it receives is the onSubscribe, which is like a signal, which is like a callback that confirms that they are connected. Then it can receive items from the producer via the onNext method. It can receive errors and completion signals via either onError or onComplete. So this is like a way for doing the communication between a producer and the subscriber. Then to represent the connection between the publisher and the subscriber, there is the subscription interface. And actually, as I said, it represents the connection, and it actually allows for the most important thing that we were talking about when it comes to Reactive Streams, which is backpressure. So subscription exposes the request method, which basically allows the consumer to request some data, like a given amount of data from the producer. And it also allows the consumer to terminate or cancel the connection, so that it signals that it no longer wants to receive the data. So this is a subscription, which is a connection between it represents a connection between the producer and the consumer. Then we have a processor, which is basically a combination of a subscriber and the publisher. So it implements those two interfaces, and the processor is both a consumer, so it can accept some incoming data, and it's also a producer, so it can produce something and send downstream. Of course, the types can be different, so it can do some intermediate processing in the middle and change the type. So the flow, once again, looks like here, you can see on the slide. So initially, we call subscribe on a publisher to connect a given subscriber to the publisher. And then the subscriber can receive the onSubscribe callback. Then it can receive an arbitrary number of onNext callbacks to receive the data. And then the processing is somehow terminated, either with a successful completion or with an error. So you are developers. And if you see those interfaces, the first thing to do is, try to implement them. So they are pretty simple. Let's see how can we implement them. So let's see. So we'll start with trying to implement a simple publisher. What it is going to do is basically it's going to have some iterator of integers. It would accept a number of integers that it needs to emit as a constructor parameter. Then it's just creating the iterator. And what we will be attempting to do is to create a producer that it's going to send these integers downstream using the Reactive Stream concepts. So the first, and I would say the most naive approach, is basically like to take the data from the iterator, send it downstream, and signal completion, because why not? So we can start with doing something like iterator for each remaining, and then we take the subscriber, and for each of the items we call onNext, which basically takes all the items from the iterator and using the onNext callback sends them downstream. And then when we have like exhausted the iterator, we can call the onComplete on the subscriber. So this is like the most trivial approach. Let's see if it can work at all. So we can try to create a main method to see whether what happens. And here we create a new publisher, let's say with 10 elements. So then to start the entire pipeline, we need to call subscribe and provide a subscriber. So we would call subscribe here and create a new subscriber. And there is these 4 methods that we need to implement. We are actually only going to implement the onNext, onError, and onComplete with some simple print statements to see what's happening. So we're only going to print the actual parameters of the methods. The same with the error callback. And here in the onComplete, we're just going to say that it's complete. Okay, so this is our simple pipeline. So we created the trivial publisher, a trivial consumer that really doesn't do much, like the subscriber. But if we run it, you can see that actually it did what we expected it to do. So this looks pretty simple, and you may wonder whether it is that simple actually, and it isn't. So this seems to work, but then if you think about all the considerations that a Reactive Streams implementation should like have in mind and the rules it should follow, you wouldn't really think that it's going to be that simple. And to actually verify that your implementation of Reactive Streams is correct, there is a library called Reactive Streams TCK, which stands for Technology Compatibility Kit, written by Konrad Malawski. And this is basically, first of all, a set of rules. But apart from this set of rules, there is like a bunch of tests that are actually verifying the components you implemented. So actually, I have a verification from the TCK for the simple publisher I've written. So let's run it and let's see what happens. So let's verify whether our like trivial implementation is correct at all. So if you run it, you can see that this is mostly red. Like there is some green test, but well, at this stage we could consider it rather random that something here is green at all. But most of the tests are red. So this is like a set of rules only for the publisher that it needs to follow and that we need to obey when creating our own implementation. So that basically when we connect it to other implementations that follow the same rules, so that it can play well nicely. So let's have a look on some of the errors. So for example, if you take the 109, which is like 1.09 in the specification, it says that there should be a non-subscribe callback when the subscriber is connected. So actually we already know that because we saw it on the slide that there should be this unsubscribe callback. And what the TCK does, it verifies it for us. So well, let's start trying implementing those rules to see if we are actually able to do it easily. So coming back to our simple publisher, I'm just going to fold the main method because we will not be using it. So instead of actually calling just onNext on our subscriber, we should be calling onSubscribe as the first thing. So if we see what onSubscribe requires, it actually requires a subscription, so there is another thing that we need to implement. So we need to create this subscription, which, just to remind, is the thing that represents the connection between the publisher and the subscriber. But okay, well, this is only one more interface to implement. So well, let's try it. Let's call it a simple subscription. And the subscription would require the subscriber, because now what we will be doing is like moving the entire communication to the actual subscription. So the subscription, as you may remember, will be dealing with the backpressure, with the request method. So we're moving the subscriber there, and I will be doing all the subscriber calls inside the subscription. So here we created the subscription as an inner class. We create a field that is going to represent the subscriber. And we still need to implement some methods because subscription exposes request and cancel. So they need to be here as well. And as I said, we'll be moving the logic of like sending the data downstream to the request method. So we'll try to somehow handle the backpressure. So we will only emit that amount of data that was actually requested. So what we are going to do here is write like a plain old for loop. And now please think when was the last time you actually wrote a for loop in Java. But this is actually like the simplest variant. So we're going to call our loop variable demand, and we're going to start from n, so from the number of items that we requested. We're going to emit until it's greater than 0, and of course we also want to emit only as long as there is some data in the iterator. So we're going to add another condition here that the iterator has another element, and then we're going to decrease the demand, so to just come down. And what we are going to do here is send the current item downstream. So basically, what we'll be doing here is calling subscriber on next with the iterator next. So this is pretty simple. But also, you may remember that when doing the trivial implementation before, the first thing we did was like streaming all the elements from the iterator. And then we signaled completion of the pipeline. So we want to do something similar here. So basically call subscriber on complete. But of course, we only want to do it when the iterator was exhausted. So we're going to check whether there is still any data in the iterator, because like the demand, the backpressure, the demand could be smaller than the number of elements. But if we exhausted the iterator, we want to signal the completion. So if the iterator doesn't have any more elements, we're going to say subscriber on complete. Yeah, you're right. Sorry. This is a good point. Of course, we are checking the demand and not the n, because it would get infinite then. Thank you. So let's now run the TCK once again and see whether we were able to solve anything at all. And actually, like the test here didn't complete, but you can see at least that like the test that we were trying to fix, so the 109 must issue and subscribe was solved. So yeah, we were able to solve one of the problems, but there are still a lot more there. So let's see some other ones that are pretty easy to fix. So for example, you have those 309 here, which basically say that when the requested amount is either negative or 0, then we should signal an error, because we don't want to handle such demand. So this sounds pretty easy to implement, so let's do it. So basically here we say that if n is less or equal than 0, and now we want to signal with an invalid argument exception. But you need to remember that we are not just able to throw an exception here, but we need to use the subscriber on error signal to send the exception like this. Because if we just threw the exception here, this would still not work, because like the way of signaling errors is using the callbacks and not just by throwing the exceptions. So we can just put a new illegal argument exception here, then run the TCK once again. Yeah, so it's like becoming greener slowly. You can see that 309 is actually passing now. But there are still a lot of other errors. And for example, some of them are related when you like have a detailed look. They are related to the fact that, for example, we are sending the completion signal more than once, and we are actually like not really handling the termination correctly. So, like, without like digging very deeply in what the errors are, I can just show you how to solve most of them. And to solve most of them, we need a flag that we will be able to set when we receive the cancellation signal. So when the cancel is called on the subscription, and then we would need to include the flag, like take it into consideration before sending on next or on complete. So this would basically prevent us from doing some things twice. So the flag here is going to be an atomic boolean. We'll call it terminated. And it's going to be new atomic boolean with an initial value set to false. And now we are going to use it in 3 places, where first of all, when the subscription receives the cancel signal, we're going to set the flag to true, because this means that our stream is terminated. Then we need to take it into consideration before emitting anything downstream, so we only want to emit as long as we are not terminated yet. So not terminated.get. So this is the additional condition here. And also we only want to signal the completion when we have not yet terminated. But also, if we are going to signal the completion anyway, then we want to check whether we were not terminated, but also set the flag to terminated, because signaling completion means that we are actually terminating as well. So it's going to be not terminated. And actually, we have a useful method on the atomic boolean called get and set, which takes the value that we can use for the comparison for the if condition, and then it sets the value to something else. So we're getting the value, and then whatever it was, we are setting it to true, but also using it we're using it for the comparison. So this basically, once again, prevents us from doing some things more than once, like terminating the stream. And if you run the TCK again, it starts to look good. So it turns out that adding this flag solved most of the issues, at least most of the simple ones, as it may seem. But there are still 2 things that are not there. So must not allow unbounded recursion, and basically something that deals with long max value. And here's the place where I'm going to stop implementing this, because it turns out that solving those 2 is really not trivial. So once again, what we are left with is 2 challenges. So the first one is, and this was the first error, was unbounded recursion. So basically, if you noticed, if we have a look at the code once again, you can see that we are calling in our request method, we are calling on next on the subscriber. But actually, what the subscriber is usually doing, it's calling request after receiving a single element. So we are getting into an infinite loop, which so that request calls on next, and then on next calls request back again. And this is actually a problem with synchronous subscribers and synchronous publishers. So if you do it asynchronously, it could work, but it's really not trivial to do it. And actually, if you see the error here in the 317, you can see that we actually run into a Stack Overflow error, which is the result of this infinite recursion. So this was the first problem, the unbounded recursion resulting from calling request and on next in a loop. And the second one, as you noticed in the test name, has something to do with long max value, which may represent infinite demand. And the problems with infinite demand are that, first of all, if you are only going to call on next for anything that was demanded, and if you imagine that, for example, long max value elements were requested, then you are basically going to run out of threads, because, well, you certainly don't have long max value threads in your JVM. But also trying to solve it in some other way. For example, accumulating the demand somehow can also get you into trouble, because if you infinitely increment the value, you're going to get to an overflow of the number. You're going to start back from 0. So once again, this could be dealt with somehow, because, well, there are implementations of reactive streams that are working, but it's really not trivial. So although we after doing some simple fixes, we ended up with only 2 errors for the publisher. Those are really not trivial to solve. So this is actually the place where you should stop. And unless you are a library developer and you want to build a library that supports reactive streams, the message here is that you shouldn't be implementing those interfaces yourself, because as you saw, they are not trivial. So there is the extensive TCK, which guards you from doing something wrong, but this is really not trivial. What you actually should be using those interfaces for is something called an SPI, which stands for a service provider interface. And this is basically a way to like expose an interop for different libraries. So you may imagine that you have a number of libraries that somehow implement the reactive streams concept. And the reason the interfaces are there in the JDK is actually to be able to like connect libraries created by like different developers together and to be able to use it in like in a unified manner. So if you look at the JDK at the moment, even before JDK 9, there already are some streaming abstractions. So like the simplest ones are basically the input and output streams. There is an iterator which of which you can think like of a streaming abstraction because it doesn't load all the data in memory at once. It can just expose some kind of a streaming behavior. There are channels in the new I/O. In the new servlet specification, which is servlet 3.1, if I remember correctly, we have this like streaming like read and write listeners. There is a SQL result set, which also usually like bases on a cursor in the database. So this is also kind of a streaming behavior. There are java.util streams starting from Java 8. And of course, in Java 9, the reactive interfaces have been brought into the JDK as the flow interfaces. So there is like a number of different abstractions here, but they are really not unified. So you are not really able to connect one with another. So you are, for example, not able to, I don't know, write a result set to an output stream and to like easily connect them. Even if you thought, for example, of like transferring data from a single file to the other using the basic things like input and output stream, you are not able to do it automatically because you need to set up a buffer yourself and you need to like use the buffer to copy data. Of course, you can use the NIO channels for that because if you saw Jarek's talk yesterday, he showed that there is like a channel has the transfer to method, which basically takes another channel and transfers. But still, it's not like it's not unified. So what we would actually like to have is a unified way to connecting abstractions like those with the simple publisher.subscribe method and connecting to a subscriber. And why would we want that? Well, first of all, this is the unification of the API. But the second thing is that if you like think of all the magic that is behind this single subscribe code, it really gives you a lot because it gives you backpressure, so like dealing with slower and faster elements in the pipeline. And it also gives you ways to handle errors, to signal completion and termination. So this is like a single call which exposes a unified API, so different implementations, different concepts can be connected using a single API, and it gives you like kind of magic, which is mainly the backpressure, but also some other things that you basically don't need to do manually. So what we are actually lacking in the JDK today is even a minimum operation set. So what we have at the moment are just those 4 interfaces. Actually, there is a single concrete implementation provided by the JDK. It's called Submission Publisher, which is basically a synchronous publisher that you are able to send data to, and then it will be published downstream. But since it's synchronous, it really like doesn't offer much from the reactive stream concept. So there is actually like from the true reactive stuff, there are only those 4 interfaces that I showed. There are even no basic stream operations like filtering, mapping, the ones you may know from any reactive streams library like RxJava, like Project Reactor, like Akka Streams, you name it. So they all have those even more advanced combinators, not to mention the simple ones like the flat filter or map that we don't have in the JDK. And actually, so here we get like to the wall, to the boundary of what we have in the JDK, and now we will start to have like a look into the future. So what it could look like, what could be improved here. So the first idea how it could be improved is an initiative from Lightband, which is called Reactive Streams Utils. And it's basically a library that's it's going to assume that there are some basic operations defined in the JDK. But also they are introducing or proposing a concept of a pluggable runtime. So basically that you could like have the interfaces in the JDK, but then you are able to like plug the concrete implementation of the interfaces with the implementation of your choice. So for example, you can choose Akka Streams to be the implementation, you can choose RxJava. And then, for example, by using this, you would be able to adapt the concrete implementation to your needs, like knowing the internals of the library. So if you're more into like having an actor system underneath, you could go for Akka Streams. If not, you can go for RxJava or anything like that. But as it often happens, here we are coming to like a bit of politics, because if you don't recognize the two logos here, like the first one is probably more common, it's Spring. The second one is Jakarta EE, which is the new Java EE with a new logo. So it's basically the Java EE renamed. And well, if you think of like Spring that has their own implementation of reactive streams, because Spring is using basically the things from Project Reactor, they are not really interested in having like all the unification within the JDK, because then where perhaps people are going to move away from Spring and then going to use the things that are included in the JDK. But Spring has its own reactive stuff from Project Reactor, so why do it? But on the other hand, there are still companies that are using Java EE, so like there are people who are interested and in like putting the unifying things into JDK so that it is there. But since this is like all mostly open source, so there is someone who would need to implement it, and when people are like have different interests and different like things that are pursuing, this may be not that easy. So there are some other examples, and just to remind you, now we are like looking into the future, because nothing from here is actually, well, not all of it is actually implemented or even thought of being implemented. But let's just try to imagine like how an ideal world could look like. So when you think of HTTP, for example, as I said, in servlets 3.1, we already have some async concepts like the listeners. And then in JDK 9, there is, and the later ones, of course, there is actually some incubating implementation of the reactive stream concepts in a form of an HTTP client. So there is a new HTTP client in the JDK. It's now in the incubating package. So, but it is there. It's being developed, and it's actually implementing the reactive interfaces. So, for example, when you have a post method, it accepts the body as a publisher. So you are just able to like throw a publisher inside, and it's going to do all the streaming stuff. So now, if you imagine that the servlet API also exposed something like a publisher, so that you could like get a servlet request and have the contents of the body and as a publisher, and then you would like to upload a file, for example, using this API, then using the reactive HTTP client from JDK 9, you would actually be able to do something like that. So just take those two publishers, connect them together, and it's just going to work. So if you think of like the task of file uploading, it's not that trivial to implement without this. But if you had like all the reactive interfaces implemented, this connecting them together would be as easy as that. But of course, the HTTP servlet request doesn't yet have anything for any publisher. So the async concepts are a bit on the side, but the reactive interfaces are not yet exposed. So the other very popular concept, I think, is database access. And now there is an initiative called ADBA, which stands for Asynchronous Database Access API. Which was proposed by Oracle, and they are really doing some stuff around it. This is basically something like an async JDBC. And actually, initially, they were trying to include the reactive interfaces in the implementation, but as far as I know, they have dropped support for it because like they have problems implementing it. So ADBA is like still being developed, but at the moment, they dropped support for the reactive stuff. So this is perhaps not going to be there, at least not now. There are, of course, some existing async connectors to different databases, but they are like first of all, they are vendor specific, so like every database has their connector, and they don't expose any of the reactive APIs. So there is actually one that I think it's a MySQL connector that exposes the RxJava concepts. But this is like an exception, and all the other ones just do like things by themselves and don't get into this unified way of exposing things. But if you like dreamt of what JPA could have in the future, like if we had something like get result publisher method on the query, then it would be really useful, because then it would like abstract everything from you, and you would just be able, instead of getting a result as a list so instead of getting a list of user here, you would just get a publisher of users. So it would be really nice, because once again it would like expose the data in a unified way, and with the API that is like hiding all those reactive concepts like backpressure inside. And what you get is just a like publisher interface that you are able to easily connect to other processor or to other subscriber, for example, and just to have the data into a single pipeline. There is, of course, more things that you can like dream of to have in the future versions of JDK. For example, reactive file I/O. So instead of using channels or instead of using the streams, it would be really nice to have like publishers and subscribers of bytes. So then like doing the file transfer that I mentioned, for example. Like you can do it with channels with a single method, but then it doesn't handle backpressure, it doesn't handle slowing down. And if we had like a reactive implementation of that, it would be really nice. So there is JMS, which is like basically messages sending, and also you could think of it like kind of a streaming pipeline, which could also include those backpressure support and reactive stuff. There are WebSockets, which are all about like sending data to the client. So this is also something that you can think of as a stream. And actually, AWS is also implementing the reactive interfaces in the Java SDK. But as far as I know, as far as I had like looked at the code, they are a bit hidden. So they are using the reactive concepts inside, and they are the communication is implemented in a reactive way. But what they are exposing is not actually reactive. But perhaps in the future they are also to expose the reactive interfaces more directly, and this would be nice as well. And there is also Project Alpaca. I don't know if you've heard of it. It's basically a set of connectors that can be used with Akka streams to connect to different like data sources and destinations. So this is basically like a reactive camel. So camel was the integration framework back then, but today when everyone is getting reactive, we have Alpaca, which offers this set of connectors. But this once again is not really exposing the reactive APIs. Well, it could, because Akka streams is an implementation of the reactive streams, and you could like lift the Akka streams interfaces to the reactive streams ones. But the question is like whether you still want to use separate libraries, or you'd rather have the things inside the JDK, so the integration abstractions inside. So now, speaking of integration, I want to show like one more quick demo, which is actually not going to show any like data sources or destinations, because as I showed you, there are not really like true implementations for that. So the demo is going to be pretty simple. It's also only going to show like different implementations of reactive streams and how they connect together. So we take a publisher using Flux from Project Reactor. We'll create a processor using Akka streams, so using Akka streams APIs, and then we'll use RxJava as a subscriber to just consume the data. So since all of those are actually implementations of reactive streams, and all of those have some support for like lifting their own interfaces to the like built-in reactive interfaces in JDK, it's actually pretty easy to like glue all of them together and show you that it actually has a chance of working. So I'm not going to write code here. I'm just going to show how it works. So basically, we start by creating the components. So we create the publisher from Project Reactor, and we will see how it looks in detail in a second. Then we create the processor from Akka streams, and then since they are exposing since their data type is actually the interfaces from JDK, so that then we can easily connect them. So we can just say Reactor publisher subscribe Akka stream processor, which like takes the publisher and connects the Akka stream processor as the subscriber. And then we can use the interfaces from RxJava, which is the flowable here, and actually take the publisher, which is the Akka streams processor, and consume it using the subscribe method, and consume it by printing the elements to the standard output. And here actually we need to use some more like interop and like unification layer, because what RxJava expects here is a publisher, but this is the publisher from the org reactive streams package. And actually the components we have above here, so the publisher and the processor, they are using the java.util.concurrent.Flow interfaces, which, as you may remember, are the same, but like the package name has changed when they were moved to the JDK. So we need an additional conversion here. Yeah, and it actually can just work. And now just to have a look at the implementation. So when we create the publisher, we actually take the Flux from the Project Reactor, and like you use some combinator that's basically going to emit a number every 1 second. And then we need to use once again, a kind of a unification layer, which is provided by Project Reactor here, which takes like the concepts of Project Reactor and converts them in terms of interfaces and in terms of the types to the reactive streams interfaces. So what it does here, like instead of the flags, it's going to return an actual publisher from the java.util.concurrent.Flow. And a similar thing happens when creating the akka streams implementation. So here we are using the akka streams API to create a flow, which in akka streams is like the block in the middle of the pipeline, which has an input and an output and does some processing. So we're basically like taking every long that arrives and we are negating it, and then it's going to be emitted downstream negated. And then once again, we're using some unification tools provided by akka streams this time to convert it to the actual implementation of the JDK interfaces. And here in the case of akka streams, it's a bit more complicated because like akka streams are directly exposing in their APIs the implementations on the things that lie under the hood, which are the actor system and the materializer that are, I'm not going to dig into details, but this is like a trade-off because some of the libraries are really hiding the internals, and actually akka streams is exposing the internals, so you can provide your own actor system, you can provide your own materializer, and you are like required to create them explicitly. And as you can see, it's also used somewhere here, but like the outcome and the bottom line is that it's going to return a processor from the java.util.concurrent package. And if we actually run it, we can see that it does what we expected it to do. So 0 is not negated, but the subsequent ones are. So basically, we've just seen how we can take different implementations of the reactive streams and connect them together. And now, having constructed this pipeline, we're actually benefiting from all the things that it gives us, like backpressure, like handling, like signaling termination, signaling errors. And of course, this is a trivial example because it just shows like simple building blocks. But once again, if you imagine that even more of the building blocks were in the JDK and the interfaces were unified, then you would be able to connect like really more complex stuff together. So this won't necessarily be like things that are printing to the standard output, but it could as well be a database. The source could be an HTTP connection or anything like that. So there is potential here, but it's really not certain how it's going to evolve, and it's like a good time if you wanted to implement your own library. Then it's really good to do it at the moment, and then you will like contribute to the JVM ecosystem, so that it can evolve. So as a summary. Well, first of all, as you've seen, this is the reactive interfaces in JDK 9 are certainly not a full reactive streams implementation, because apart from the synchronous submission publisher, there is actually no implementation at all. So the interfaces are just there, and the goal they are here is that you use them as an SPI, so as the service provider interface, which is basically a layer of interop between different implementations. And as we've seen with the TCK and with all the tests we are running, implementing those interfaces yourself is really not trivial. So we tried to implement the publisher, which is, well, it was complicated, so we ran into some non-trivial issues. But this is not the most complicated thing you may think of. Actually, implementing a processor is even more complicated. So of course, it's not like you shouldn't really be doing that at all, because if you want to implement a library, you are free to do so. But just don't do it as the first thing when you see the interfaces. Don't just go implement them. Use the existing implementations. And if you choose to implement them in yourselves, you should really be using the TCK, because this is like kind of a guarantee that it is going to work well together with all the other implementations. Of course, there can still be some errors. So there was some like recent bug in akka streams that was discovered like after a few years, and it actually has to deal with some like nuances of the reactive communication. So even though there was the TCK, it was not covered. But if you saw that the TCK is like pretty extensive, and there is really a number of tests, so there is like a good chance they will guard you from at least the very basic errors. There are some resources that you can have a look like. So this is the pluggable runtime. So the implementation that you can just use by providing like a startup parameter to your application. There is the TCK, which so the TCK is not only test; it's also like extensive specifications with all the rules outlined and with the reason why the rules are there, with the description. So if you are like eager to learn what does it mean to implement a truly reactive library, then it's really a good place to start from and to have a look at. Because those are like all the concepts are really covered in detail, so they are explained. There are test cases, so this is a very useful thing. There's a blog post about ADBA, so the async JDBC or the JDBC next. And as I said, unfortunately, it's probably not going to have those reactive interfaces anymore. But still, you may want to just have a look at it. And there is a nice blog post series about advanced reactive Java. So this actually gets into more detail about implementing a correct version of all those interfaces. So if you are if you want to learn in more details and see how you could do it in a right way, or at least to adhere to the TCK, then this is a good place to go to. So thanks for coming once again. I'm happy to see still that many people here on Thursday morning. If you have any questions, either about the talk or about software mill, you can ask now. You can catch me later. I'm here until tomorrow, lunch. Thank you. There was a question there.
Okay, is it possible to implement splitter pattern with the streams?
So the question was whether it's possible to implement a splitter pattern. So by splitter, you mean a stage that will be broadcasting the data, yeah? So it has one input and several. Well, I think it will be possible. So it's like the data types of the processors are flexible. So basically, whatever you choose as the output type is going to be there. But of course, the question is how trivial or non-trivial it's going to be inside. So the interfaces are there. So if you, I think you should be able to do that. One more question here at the bottom.
Thanks. So the TCK verifies if the library I created is, let's say, valid in this reactive string pattern. Is there any similar solution to test my own code? So my usage of, I don't know, Akka, Eric's Java reactor, if I'm respecting all this stuff?
Well, not that I'm aware of, unless you have written your own. So if you've written your own subscriber, so something that implements the subscriber interface, then you have the TCK for the subscriber, and you can run it against your subscriber to verify whether it behaves correctly. But if you don't implement the interfaces, but just want to test a part that it's not implementing anything, I'm not aware of anything like that.
Thanks.
Okay, so I don't see any more hands, so thank you once again, and feel free to catch me later if you wish.